Good morning, everyone. Welcome in the first webinar of the series of webinar. The first one is called The Challenge in the Copper Supply Chain, and it's part of 3 webinars we are co-organizing with the partners of KU Leuven, Make ICT Fair and Fair ICT Flanders. And today we're going to talk about the challenge in the copper supply chain. This webinar is part of Make ICT Fair. Make ICT Fair is a project of 11 European partners who joined forces together in 2017. And we try to reform manufacturing and mineral supply chain through policy, finance, and public procurement. These diverse partnerships aim to improve the life of workers and local communities impacted along the ICT supply chain through research, capacity building, and campaigning. 3 years later, because we are 2020 now, this consortium is hosting a series of webinars to share the results, pleading for increased transparency in a fair ICT supply chain. In 3 webinars, the different links of the ICT supply chain from mineral extraction to manufacturing and assembly are analyzed. The key results of the research will be presented today, and the following questions are debated today. Which levels in the supply chain could drive a fair ICT supply chain? And what are the opportunities and calls to action? These webinars aim to stimulate an open discussion with the sector to achieve a fair supply chain for electronics devices. Make ICT Fair also joined forces with Fair ICT Flanders, which is a more local project here based in Flanders, funded by the Flemish government. And Fair ICT Flanders aims to provide private companies, local authorities, and higher education institutions in Flanders to take concrete steps to develop a sustainable ICT purchase and use policy. The project is financed by the Flemish government, and it started 1.5 years ago and it will go on for almost 1.5 years. So you can also check this on the website. Before we start, I would like to give the word to Professor Mark Krabs, who is the leading professor of this webinar at the KU Leuven, and he will welcome you all on behalf of the KU Leuven.
Hi, good morning, all of you. So it's really a pleasure to welcome you in the name of KU Leuven. I hope you can hear me all. Yeah. So then, as Charlotte introduced me already, I'm a professor at the Faculty of Economics of the KU Leuven in Brussels, where we have a Center on Corporate Sustainability. And it's good to mention also that we are organizing this webinar in close collaboration with SimSquare. And SimSquare is a center at KU Leuven for sustainable materials and minerals. And so as a Center for Corporate Sustainability, we have established also a close relationship with this center. Because for many years now, we are trying also at our university to put sustainability high on our research and teaching agenda. And when we're talking about corporate responsibility, so we think indeed that for companies, it's their responsibility to contribute to a fairer and more sustainable society. But to reach that, it's still a long way to go. So there also our collaboration with civil society organizations is really necessary, because they can also bring us direct testimonies from communities, from actors that are affected by company practices, especially also in the extractive industry. And so this webinar is also a result of this. Maybe we organized already in the past like 3 symposia, but and those symposia, they were really also a very good opportunity for informal conversations with people belonging to different areas, to different sectors also. But for reasons I do not have to explain too much, the COVID-19, so such a symposium this year was not possible. That's why we switched to the webinars. But I think also that has been also a huge opportunity, because in that way also now we are able to reach out to much more participants than the years before. So I think also that is a great opportunity for many more people all over the different places to take part in this. I have to apologize for today. For instance, I have a teaching duty that I cannot assist in the session today. But from tomorrow on, and also on Wednesday, on Thursday, I will be part of it, and I'm really looking forward to the presentations and to the debates that will follow on it. And I wish all of you good luck.
Thank you very much, Professor Mark Krabs. So yeah, as the professor already announced, we also have a webinar on Thursday at 10 o'clock about artisanal and small-scale mining as part of a fair global supply chain. And on Friday, we also have one on trade union rights in the global electronics industry, the case of Indonesia. For today, we started with an introduction of Professor Mark Krabs. Then we will listen to the presentation of Linda Scott Jakobsson, who is working at Swedwatch, which is a Swedish organization. Then we will listen to the presentation of Daniel Popov, who is working for Bankwatch Network. And after that, we will listen to the presentation of Dr. Xiaohua Li, who is working at the SOLVOMET Group at KU Leuven, which is also part of SIM Square. And then at 11:05, we will start with an open discussion and some questions and answers. Before we start, I want to share some more practicalities. So participants cannot unmute themselves. If you have questions, please put them in the chat box. We will address them after the three speakers have given their presentation. If you have a particular question to someone, please put their name in front, because then we know this question is going, for example, directly to Daniel. This session will also be recorded, so if you don't like, please feel free to switch off your camera. We are also very pleased to announce that we work together with Iris. She's a graphic designer, and during this webinar, she's also making a graphic design who is summarizing a bit what's been told today. So we will show and share this drawing after to you too. Every presentation, we start with a poll, so you can vote on your screen, and then we will talk about results and explain to you what is the right answer. And after this series of webinars, you will all receive the recording, the drawing which Iris is making, the evaluation form, and also a blog spot. And if you want to share some information about this webinar, please use the hashtags hashtag SDG or hashtag Make ICT Fair. So we are very honored now to listen to the first presentation of Linda Scott Jakobsson. She's a researcher and public procurement specialist at Swedwatch. She's working for the non-profit organization Swedwatch. Linda has a long experience of working with contracting authorities on sustainable public procurement in Sweden, in particular how human rights criteria can be incorporated into the procurement process. She did a case study on the impact of copper extraction in Zambia in the frame of the Make ICT Fair project. So she's taking us now to Zambia and will give an overview of what is happening there with the supply chain of copper.
Thank you, Charlotte, and good morning, everyone from Stockholm, or I'm in Stockholm. Thank you for having me. It's really exciting to be able to present on our research in this webinar today. Also looking forward to the coming webinars, which will be very interesting to listen into. So yes, I think Charlotte introduced me quite well. Very short point on Swedwatch is that we're a non-governmental organization. We're independent. We're working in the field of business and human rights, and we do research on how business and how investors are impacting human rights and the environment in their global supply chains. And we cover different sectors, and we also cover geographically Africa, Asia, and Latin America. And we are part of the Make ICT Fair project. We have done research within this project on copper extraction in Zambia, which I will focus on today. But we also did a report that just came out in June on exposure of toxic chemicals in the manufacturing of electronics in the Philippines. Everything is available on our website, of course. Yes, so next slide, please. No, sorry, the poll. I forgot the poll. I think we will have a poll, yes. So just to get your minds going a bit this morning, I have prepared some questions. So we have lots of minerals in ICT, and some are called conflict minerals, but what are those? Interesting to see if you know this fact. So we have 70% who voted. And yes, we have a quite clear winner. 58% choose the right alternative. Tin, gold, tungsten, and tantalum are the 4 conflict minerals. So well done on that. And I will not speak about any conflict minerals today, but I will speak about copper, as this webinar is on copper. I'm just going to have to close this window, sorry. So, yes, so we did research in Zambia back in 2018. And we released a report, Copper with a Cost to Human Rights and Environmental Impacts in the Mineral Supply Chains of ICT in 2019. So just as a background, copper is, of course, a very important part of ICT and electronics. It's in every kind of electronic device you would come up with. And why focus on Zambia? Well, as you can see in this picture, Zambia is among the big players when it comes to extracting copper. Okay, so now we have, thank you. We can stay on this picture a little bit longer. Of course, you can see that Chile is the world leader when it comes to extracting copper, followed by Peru, but then there's many other countries also doing this. So copper can basically be extracted all over the world. And it's also interesting to focus on Zambia, as it's like a high-risk context really for extraction in general, with a very weak law enforcement and high corruption and weak institutions. And we can go to the next slide, please. So just also some background on Zambia. It's a landlocked country. It's a population of roughly 17 million people. It's in the southeast of Africa, and it's very rich in minerals. Copper and cobalt are the key commodities, but there are also other minerals extracted in Zambia. And however, even though very rich in minerals, roughly 60% of the population live in poverty. So it's not really benefiting the general public or the inhabitants. So it's actually the home of the largest copper reserve in Africa. And as you saw in the previous picture, Zambia is the second largest producer of copper after the DRC. Large-scale copper mining has been going on since the 1920s. Of course, artisanal and small-scale mining has been going on for centuries before that as well. And they have really tried to get an increase in foreign direct investments from international players who have come into Zambia and started to extract minerals, getting licenses to do that and then export, basically. So there are lots of foreign companies present in Zambia currently, and many Chinese mining companies, not the least. And mines are located mainly in what is called the Copperbelt province, which you can see on this map. It's just on the border to the DRC. And because there's been so much mining going on here for such a long time, there has been a very extensive pollution of this area over the last century. So there has been an assessment of 10,000 hectares of land is contaminated due to mining. And I will go into one example, which is the Nachanga copper mine in Shingola. You see Shingola here is just on the in the Copperbelt province. So we can go to the next slide, please. So the Nachanga copper mine is located in Shingola, which is a very vibrant town. It's owned by Konkola Copper Mines, which is in turn owned by Vedanta Resources, which I think maybe some of you have heard of. It's a very large metal and mining company investing in mines all over the world. So it's majority owned by them presently, and then also to the minority by the state-owned investment company as well. And the next slide, please. So basically the Nachanga mine is a huge mine. It's one of the largest open pit mines in Africa. It's been operating since the 1930s, and it stretches 6.5 kilometers across land and almost 500 meters deep. And it's actually not just one pit, it's several pits and also an underground pit or mine. And they also have a smelter and refinery and tailing leach plant here. And it's just like part of the city. It's very weird because it's not like, oh, out in the outskirts somewhere. It's really just there in the city. And you can really see this on this picture, that people actually live just on the edge of this pit. And we visited Shingola and we talked to the people living in Shingola, and we also visited people who live just on the edge here. And they told us that heavy blasting caused severe damages to their houses. So we can see that in the next slide. Thank you. So here we can see one of the houses that has retrieved severe cracks in the walls. And people were super scared, of course, that the walls or the roof would just cave in. And there was also this problem with dust from the heavy trucks that gave people like breathing problems or problems like respiratory problems as well, also among children. And this is an issue, I mean, we have seen this kind of problems also in South Africa and elsewhere. So this is not just like a one thing impact, like a very unique thing. It's really it's a big problem when it comes to large scale mining. And the next slide, please. So when you arrive in Xingola, it's kind of weird because you see all these peculiar hills everywhere, and which is kind of strange to see because it's also kind of flat elsewhere. But then you realize it's not actually hills, it's slag piles and waste piles. It's the overburden from the mine. And these are placed a bit everywhere around Xingola. And these are really make out a huge risk to the environment and people in the surrounding area, because these contain heavy metals, and in contact with air or rain, it can release acid like sulfuric acid, and it can go into the soil and water streams around when it rains and pollute the surrounding area and farmland. And we have some examples of that from Xingola as well. So we can go to the next slide. So we talked to people from the Chabanyama community, and they are farmers. They grow crops, avocados, mangoes, and so on, and then they sell that on the local market. Now, they have been growing these crops since the 1960s in the outskirts of Xingola. But some years ago, the mining company started to dump mine waste in these areas, which caused heavy pollution of the land and also of water streams that they used for irrigation. So they have not been able to grow crops there for some time. And this is actually the waste pile that we sort of climbed up on, and we couldn't even reach the top because it was so huge. And this impacted their income levels, of course, their livelihoods. They couldn't sell any crops. They didn't have anything to sell anymore. And also their food security, because they couldn't grow food. And subsequently, this also caused impacts on their children's right to education, because they didn't have the money to send their children to schools, or at least not to higher education. Like one young man also told us that they were stranded, and he used to have good grades and go to school, but suddenly he was not able to study anymore. And this, of course, caused a lot of despair among the younger community members, of course. Okay, next slide, please. And the third example and the final example from Zambia is from the Shimolala village just outside of Xingola. And they have this stream going by, which also passes by the mine. They are also farmers, and we could see similar impacts, just like the Chabanyama community experienced, because so they told us that from the mine there was release of like toxic wastewater that hadn't been cleaned properly or leaked out into the stream, and flooded their farmland, which was used to be on the riverbanks along the stream that you can see in this picture. And it used to be like very fertile soil, so it was very good for crops to grow there, but then they experienced that they could no longer use this land because it was too acidic and polluted to grow anything really. So they also experienced these impacts on income levels and their livelihoods. They couldn't grow any food. They had impacts on their food security, and of course also access to clean water, which is also a human right actually. So, and this was a stream that was also important to people for just domestic use, like bathing, washing clothes, fishing, and so on. And for this, they have actually come together with some other villagers in other villages who and sued the mining company. So they have a process going actually in a UK court. And what we also could see from this research was that this is, again, it's not like a very unique example. It's something that is going on in several countries in the DRC but also in elsewhere. So large-scale copper mining is really impacting the environment and subsequently also the human rights of the people living around these mines. And we can go to the next slide. Yes, this is just a picture of Shimulala village as well. And the next slide, please. And here's the water that they extract from their wells. And the next slide. Thank you. So I've already started to talk about this, but the conclusions are that environmental pollution cause human rights impacts in large-scale copper mining in Zambia, but also elsewhere, concerning livelihoods, health, right to food and water, rights to education, and also that it contributes to these social impacts when there is so much despair and young people do not feel that they have any future really to go to school and educate themselves. They turn to like a more destructive living, which some mentioned that their children were just, some turned to alcohol and drugs and even prostitution to provide for themselves. So it has all these huge impacts. And we also did some research on how ICT electronics companies sourced minerals, or like their policies on that, or how they work with different minerals. And our research indicate that there is a very clear focus on conflict minerals still, which is of course super important, and also cobalt to some degree, growing degree, but like beyond the scope of those minerals. Our research indicate that ICT companies are not working that much with other kinds of minerals, and that is something that we think that they really should do and really widen that scope. And also we could conclude, of course, that these practices, these mining practices, completely contradicts the Sustainable Development Goals. So next slide. So our recommendations to mining companies, but also to the ICT brands sourcing different kinds of minerals, is really to improve human rights due diligence, meaning to like assess the risks and act on these impacts. And when it comes to the mining companies, really set up better cleaning system, management systems to reduce these kind of waste piles and emissions to water, land, and air, and of course remediate these impacts and restore livelihoods. And of course also for the ICT brands to like widen the scope of what kind of minerals they're working on and tracing and so on, because there's a very limited traceability in minerals in general. So that also needs to be improved and made more transparent. And then we also have some recommendations to public buyers. I don't know if there are any public buyers present in this call now, but we at least think that they need to implement social criteria in their procurement practices of ICT and also include minerals, and not only conflict minerals then, but also address other types of minerals. And we also recommend EU decision makers to reassess the scope of conflict mineral legislation, which comes into force next year, and to widen that scope as well, and also include other types of companies, not just importers or smelters, but also those who provide like finished goods, like ICT products, for example. Okay, that was my presentation. Next slide, I think. Yes. So I'm looking forward to your questions, and thank you for listening so far.
Yeah, thank you very much, Linda. Yeah, and I repeat myself again, if you have some questions towards Linda, please put them in the chat and we will go through them after 11. So our next keynote speaker is Daniel Popov. He's national campaigner for Bulgaria at the Central and Eastern European Bankwatch Network. He currently lives in Bulgaria. Daniel graduated with a degree in geology from Sofia University, and for the last 50 years has been working on different mining projects in Bulgaria and abroad. As the main focus of his activity, he has been demanding improvement of different projects, as well as amplifying the voice of the affected communities. And this is also exactly what he's going to bring today. He did a lot of research already with affected communities, and yeah, we would like to have their voices also represented from the case of Bulgaria. So, Daniel, you are free to share your screen now.
Yes, thank you, Charlotte. I just want to start with the fact that our region, since I live in Bulgaria, but the entire Balkan region is very, there are a lot of appetites for mining. And I want to show you this case because the difference between the presentation of Linda and mine is that the ore is extracted in the European Union and then is transported to the other very far part of the world, and then it's transported again to serve the metal markets. So it illustrates very well a number of issues and complications on the metal supply chain. I will switch off my video to not overload the connection, and I will share the screen for my presentation. Okay. So we are speaking about the Canadian registered company, Dundee Precious Metals. They have 2 mines in Bulgaria and operates a copper smelter in Namibia. They had also other mining operations, which will not be subject of this presentation, but I wanted to underline that we are working on this company projects for already more than 15 years, and we have a lot of experience of all the issues, but also we made contacts, and I can say that after all these years, we more or less obtain certain level of good communication with the company. So you can see on the map, how the material is transported, how far is transported, and later in the presentation you will see the impact of it. Just a second. Okay, so the Bulgarian gold and copper mine is relatively a small mine. The production, the ore which is mined in the moment is above 2 million tons for 2019, and the copper and gold concentrate produced annually is about just below 100,000 of tons. And there is a reserve, proven reserves for maybe another 10 years. And generally the content of at the ore is estimated as 3.40 grams per ton of gold, 6.22 grams per ton silver, and about 1% of copper. And the smelter in the Namibian town of Tsumeb is situated at the northern part of the country. I want to underline that is specially designed for treatment of complex copper concentrate. complex we are using other language. We are calling such a complex concentrate dirty concentrate, because a part of the number of different metals that they are concentrating that they have, it's also a number of toxic components that comes with the ore. And of course, it's not, the company is owning the mine in Bulgaria, owns the smelter in Namibia, but is not the owner of the concentrate. Once produced, the concentrate is sold to an international seller, a commodity company, and this company is transporting the concentrate to Namibia, is paying to Dundee to smelt the concentrate, and then is the owner of the metals further. So it's one of the issues that prevent us to have a very clear knowledge about the whole supply chain of this particular gold or copper. It's one of the major obstacles, and it should be subject of further elaboration of the standards. And also, of course, the smelter is operating as the Namibian Export Processing Zone Act, which makes primarily the company to not pay any taxes about their operations or machines or any kind of other investments. Practically, they are paying taxes only for their particular individual income taxes about the employees. And here, from our perspective, is the elephant of the room, because the Chelopech complex copper concentrate has 5 to 6% of arsenic content. The evaluation of the total reserve of the Chelopech ore is about 100,000 of tons. So this arsenic, this high arsenic content after an accident in the 1988 led to a governmental decree to ban the treatment of this concentrate in Bulgaria. And this was primarily one of the reasons to Dundee to purchase the smelter in Namibia. But also the SOLVOMET smelter is not treating only the Bulgarian concentrate. They are taking parts of they're taking concentrates from other parts of the world, including Peru, where the Peruvian mining company El Brocal is reported to have even higher concentration of arsenic in the concentrate at the level of 7.2%. So having this in mind, for us, one of the main questions is this operation, the transport and all the treatment of this metal normal economic logic, or it is created just because the company has to get rid of the very high toxic arsenic from Europe? And why the arsenic issue is so problematic? It's about the question in the poll that we might I missed to announce. But anyway, the question was if there are safe levels for arsenic exposure. And yes, there are certain guidelines or regulations defining levels, but these are levels of different level of risks. For example, the South Africa have such standards, and the company is the Dundee Precious Metals is very proud that they are keeping within the South African standards, but practically according to the World Health Organization and European guidelines, there is no safe level for arsenic exposure. Also, the compounds of the arsenic are evaluated as carcinogenic and a substance of a very high concern. But also the Basel Convention is identified wastes having as constituents copper and compound and arsenic compounds as a hazardous waste. And the Constitution of Namibia states that it's forbidden of any dumping of foreign nuclear or toxic waste at Namibian territory. And according to the proper documents of the company, for example, the 2014 sustainability report of Dundee Precious Metals, they are very clearly identified that after the copper concentrates has been smelted, the extracted arsenic is classified as hazardous waste. You can see on these pictures, on the pictures on the right, you can see the site of the smelter and the arsenic dump site. You can see there is a small hill between the dump site and the residential areas of the town of Tsumeb, but you can see how close this is. And this is the state of the hazardous waste facility, which we saw in our first mission in 2015. The other pictures have been provided to us from local workers or activists. So you can see that the arsenic is stored in plastic bags, which had the inscription that they are coming from a local ware store for sugar. And all these have been opened to the dry sun and to the Namibian winds during all these years. And on top of that, the waste facility have been filling with a very high speed. And one of the most important issues for me, as I work primarily with the documentation, that we were surprised to see the lack of any documents, permits, or technical documentation on the smelter operation, either online or in Dundee Precious Metals offices. This was a very surprising, because usually their practices in Bulgaria, all this information, you have it public, and you can access it and you can work on it, but not in the Namibian case. And we were not able to obtain this information or permits or technical documentation during our 15-day visits. Even we asked the company, even we asked national authorities. So it's a really big issue for me, but there are other big issues also. There was a number of reported cases of health issues, because when Dundee started to export the concentrate there in 2008, and then purchased the smelter in 2010, already there was indication from the workers that the higher arsenic level of the smelted concentrate brings health problems to them. And the issue became so big that finally the national authorities have ordered a health study, and the study proved that there is a high content of arsenic in the blood and the urine of the workers. So the measures that was undertaken in that time was that the authorities forced the company to reduce the quantity of concentrate smelted. And this ban was lifted in 2012, where it was estimated then that the condition in the smelter have improved. But also, since it's again an old smelter and there was a mining business also developed during the last 50 years, there is a lot of legacy issues and severe soil contamination. So our usual intervention is to have a constant communication and demands to the company, but also to the relevant national authorities, and also to the European Bank for Reconstruction and Development, which are lending money to the company. And of course, to facilitate the connection of local activists to other communities with similar problems around the world. And things have changed. The company adopted, after the pressure, of course, not only for us, but also from the national authorities and the European Bank for Reconstruction and Development, they adopted several important action plans, including for the arsenic exposure. And a significant reduction of the emissions have been already recorded. And in 2016, it started environmental impact assessment procedure conducted by independent consultant, which gives much more clarity about the technical issues and the papers that were missing before that. So it was a very good process, which ended just at the end of last year. And in 2017, the arsenic facility, the fabric which was producing the arsenic trioxide, was decommissioned. And there is significant improvement of the management of the hazardous waste facility. It's already covered, it's sealed, and they started to operate a second sale of it in a much better condition. And the company is investigating the introduction of a facility for vitrification of the arsenic dust. It's one of the options discussed in the EA, which will really reduce the harmful effect of the arsenic practically to zero. And of course, during the studies of the EA, were elaborated a very detailed studies on the soil and the underground water pollution. So what's still to be improved? Again, we have to increase, the company should increase and the national authority should increase the transparency to ensure the industrial application of the arsenic vitrification technology. And most important, even the smelter is working better with smaller emissions now. The issue of the mining legacy should be solved out. Otherwise, the local people are suffering from the same issues as Linda mentioned. They are gathering food of polluted territories, and in some of the parts around SOLVOMET is even forbidden that they grow their own food, which is not fair at all. And of course, ensure compliance with the higher standards for worker rights and health. Last conclusions about the supply chain. So the extraction and the treatment of metal are most often cause local human health issues and environmental degradation. My personal opinion is that the nature of the business is so dirty that even a company is trying to do better, it's very difficult, nearly to impossible. if the environmental impact assessment procedures are conducted as they should be in the highest standard, I don't think that any mine will be allowed to open. And it is almost impossible to trace the metal from the extraction in Bulgaria to the final products, which was one of the purposes of our ICT project. So we need much better public reporting in all the stages, but also all the partners of the mining and smelting companies, like the trade companies, and also the corporate financial logic, as for example the tax optimization, often leads to harmful climate practices, because maybe it's cheaper for the company, but to transport the materials all across the world, it's causing a huge climate impacts. And maybe another very important issue is that some of the metals in the Bulgarian ore, the Chelopech ore, including critical raw materials as the germanium is, are not subject of the extraction concessions. They are not even calculated to be paid as a concession fee, and practically we don't know at what level they are separated from the copper, the black copper blisters, or even if they are separated at all. So more or less this is my presentation, and you can find a lot more on our cases in the web page of Bankwatch. You can find a very good report about the Namibian case from 2017, which describe very in details the issues. So thank you, and I wait for your questions.
Thank you very much, Daniel, and also for stressing once again the transparency and mentioning that, yeah, it's not only about reporting and about more administration, but also to use this transparency as a tool to improve this supply chain. Okay, then we can go to our third keynote speaker of today, who is Dr. Xiaohua Li. She's a postdoctoral researcher at the SOLVOMET Group at KU Leuven, working also for SimSquare. And she obtained her doctoral degree from University of Twente in the Netherlands in February 2017, and started her work on the SOLVOMET project in KU Leuven from November 2016. In September 2019, she obtained a postdoctoral grant to develop a new ionic liquid-based aqueous biphasic system for rare earth metal recovery. Her main research interests include separation technologies, solvent extraction, leaching, metal recovery, solvometallurgy, aqueous basic system, and ionic liquids. We're very happy to have her here because we will also have a more technical, more perspective from the engineers on how can we address this challenges and issues in the supply chain. So please, Sharon, if you can share your screen, and then we can listen to your presentation.
Okay. Good morning, everyone. I'm glad to be here to give this presentation about the new technology of copper extraction. So we will first show the poll, please. So the question is, which metallurgical processes have you heard for copper extraction before this presentation? Okay. So we can see from the results that most of you have heard hydrometeorology and pyrometeorology, and only 20%, 8 out of 38 people have heard solvometeorology. This term is quite new, and it's developed by Professor Koen-Binnemans 5 years ago from his ERC Advanced Grant. So today I'm going to give you an example of solvometeorology process. So as we all know that copper is a very important element for our electronic world, for our modern society. So in this YouTube video, they give a lot of information about copper, the examples of copper applications, the geology of copper minerals, and how to extract copper from the Earth's crust to produce metallic copper, and the properties of copper. So the examples of copper use are electronic wires, electromagnets, antennas, wireless, and integrated circuits. These are very important for our modern technology. So you can see copper is a very important element. And in the Earth's crust, copper is mainly present in the form of copper minerals, copper sulfide and copper oxides. To produce metallic copper, we need to extract copper from these minerals. So conventionally, the processing of copper ores includes several steps. They need to be mined from the ground, transporting to the place where they have the facilities for extraction, and primary crushing to crush the big particles to small particles, and then go to the chemical metallurgy for extraction of copper to produce high purity of copper metals. For the metallurgical processes currently, for oxide ore, the hydrometallurgy process is the main method, including leaching of metals from the ores and by solvent extraction to separate different metals, then electrowinning to get pure metal. For oxide ore, because the oxide is easily to dissolve in acids, so hydrometallurgy is the main method. But for sulfidic ore, the pyrometallurgy is the main process. From after frost flotation and thickening, we get the mineral concentrate. Then by smelting process, the copper is extracted from the ores and then goes through electrolysis to get metallic copper. These are the conventional methods. As we see in pyrometallurgy, the smelting is a chemical process to extract the metal, but this is a high temperature process. The temperature is normally higher than the melting point of the metal. So it's really a high temperature, and also due to the sulfur present in the sulfidic minerals, the SO2 was released during this reaction. It can be captured to produce sulfuric acid, but there's always safety risk for this process. And moreover, this pyrometallurgy process is only economically feasible for copper-rich feeds. So now the copper grade in the minerals are decreasing day by day. So many researchers have developed the hydrometallurgy process, and also in some industrial scale, it's also used hydrometallurgy to extract metal. In hydrometallurgy, we have, it's based on water solutions. So it can be acidic chloride media or sulfate media. Also, it can be basic ammonia solutions. So in this media, together with the oxidizing agents, such as oxygen, ferric sulfate, ferric chloride, or cupric chloride, and so on. There are also other developed oxidizing agents, but Most of these process can extract copper to some extent, but it's not completely due to some reasons. For example, the low extraction efficiency in sulfate media is because the formation of passivation layer on the surface of the particles. So the extraction cannot reach to 100%. And also the extraction is quite slow. The kinetics is quite slow. Also in the chloride media, there is the problem of corrosivity. And it's difficult to electroweigh high-grade copper from the chloride media. Also, when we use the ferric oxidizing agent, the acid concentration needs to be very high to avoid the formation of iron precipitate. Because when you reach certain pH, the iron can have hydrolysis to produce the precipitate. So it is very necessary to develop a new efficient process and also environmentally friendly process to extract the metals from the minerals. We have this solvometallurgy term. It is used to describe the extraction of metals using non-aqueous solutions. The examples are leaching, solvent extraction, and electrodeposition. Traditionally, all these processes are processed in the aqueous solutions, but in solvometallurgy, we use organic solvents to extract metals. So we have an example to extract copper from sulfidic ores using solvometallurgical process. In this process, we mix the chalcopyrite, one of the copper ore, with the organic lixiviant, with ethylene glycol as the solvent and ferric chloride as the oxidizing agent. Mixing these two solid and the liquid, we can leach the metal to the liquid phase. So the copper and iron goes from the solid to the liquid phase, and the sulfur is produced as solid elemental sulfur, as a solid residue. So this leachate can directly go to electrodeposition, then to produce the metallic copper, and at the meantime, the iron 2 can be oxidized to iron 3. So this iron 3 can be reused in the next cycle for next leaching of chalcopyrite. So this process is a closed loop process, although we have part of the iron 2 as a byproduct. But we have leaching and electrodeposition, only 2 steps. We can produce the metallic copper and regenerate the oxidizing agent. This is an example of chalcopyrite. We also have tested other sulfide minerals, for example, the chalcocite from Sweden, from Mexico, and digenite from Norway, bornite from Sweden. All these copper minerals contains copper and iron, and some of them contain some other impure metals. So from this figure, we can see that the copper leaching percentage can reach 100% for most of the minerals. This is not reach 100% because in chalcocite there is 58% of copper. So the copper content is really high. If we add more lixiviant, the copper can be leached more. So in principle, if you add enough organic lixiviant, we can also reach 100% of leaching efficiency for copper. So after leaching, we directly electrodeposition copper from the leachate. It's from organic solutions, so also one part of the solvometallurgical process. From this SEM figures, we could see this cubic copper crystalline was produced, and the EDX analysis shows that this copper is quite pure without the contamination of iron. And so it is a really closed loop process, and the reactions are quite simple. In leaching process, this cacopyrite reacts with iron chloride to form the iron 2 and copper 1 ions and elemental sulfur. This elemental sulfur is solid. It is an advantage of this process because this solid sulfur is easily to be stored, and instead of the production of sulfuric acid, the production of sulfur can decrease the use of neutralizing agent in the downstream processing. So in the electrodeposition, the reaction is also simple. The copper is reduced to metallic copper and iron 2 is oxidized to iron 3. Then this iron 3 can be recycled. So this is a simple chemistry, but there are many advantages of this process. The solvent we used is ethylene glycol, which is considered as green solvent. It has also high boiling point, so very less vapor pressure and can very less effect of environmental pollution. And no mineral acids involved in our process. As we have heard in the previous presentations, the acid drainage always give pollution to the water systems. So in our process, there's no mineral acid involved. So we can avoid the acidic pollution in the aqueous system. And for most of the minerals, we can reach 100% of extraction. Then the copper can be completely extracted from the minerals. Then the solid residue can be safely stored. And the reaction condition is not very harsh, it's quite mild. The temperature, the relative temperature is quite low. It's at 90 degrees, we can reach 100% of extraction in short time, but this temperature for sure can also be lower. Then the extraction time needs to be prolonged. The pressure is at atmospheric pressure because the high boiling point of the solvent. So we also don't need the autoclave. So the capex cost is also lower than the pyrometallurgy process. Sorry. And the energy consumption is low compared with the pyrometallurgy because in pyrometallurgy process, the temperature is really high, and also the low environmental impact. There's no acids, there's no air pollution, and the solid residue can be stored safely. Most importantly, we have the closed loop process. All the chemical agents we can reuse. So the waste streams are quite few compared with the conventional process. So compared with the conventional process where we use hydrometallurgy and pyrometallurgy, here we use the solvometallurgy process, which can avoid the disadvantage of the conventional process. This process cannot only be used in extraction of metals from ores, but also can be extracted from industrial process residues, production scrap, and urban waste. So and also dissolution of elemental metals. This oxidative dissolution of elemental metals can be used for the recycling of metals from the end of product. So it is also relevant in that process. Now we only have this research in lab scale, which is based on the scientific research. To implement this process in full scale, we need to study the pilot scale, which we need to involve in the industry sector, collaborate with engineering group to study the process in the aspect of engineering. And then we hope in the near future, this process can be implemented in full scale, can really ensure sustainable process, be environmentally friendly, and also economic feasible. Okay, this is my slides. And here I want to acknowledge the financial support. I'm sorry, this is always automatically go to the next slide. Okay, so I would like to acknowledge the FW grant for my postdoc fellowship and the ERC Advanced Grant to Professor Koen Bienemans and the SOLVOMET Group at KU Leuven. Thank you very much. Look forward to your questions.
Thank you very much, Sharon. Also to show that these technical improvements we as social scientists have in mind are not always as easy as we think it. It can be organized. So yeah, there are some technical limitations we should take into account always when we are proposing new alternatives. So that's why we keep on stimulating dialogue between social scientists, activists, NGOs, academics, because we should all work together to improve this impact of the supply chain. So yeah, I see we have less than 20 minutes left now to go to some questions. Some questions were already asked here in the chat. We have a question about what is the situation in the DRC? It's a question to Linda. Formerly, Zambia served as a hub for DRC to evacuate minerals notable to China. Can you say something about that? Linda?
Have to unmute myself. Yes, thank you. Yes, I will try. So, I mean, the situation in the DRC in general, of course, is very problematic. And I think many of you know about this, the situation and the connection between mineral extraction in general and the violent conflict, the armed conflict that has been going on there for a very, very long time, causing a humanitarian disaster. And I mean, it's really a crime against humanity, I would say, and a huge impact on local communities linked to these violent clashes between different military groups and armed groups. People are like local community people are murdered, raped. People are need to leave their lands, their homes. Of course, this really supports the perpetual poverty also in the DRC. So I mean, most of the time we're talking about like small scale artisanal mining, where like military groups take control of these mines and sell these mines to continue to finance their war. And that's like the connection between mineral extraction and armed conflict. Now, of course, there's lots of large scale mining also going on in the DRC, and it's copper mining, it's cobalt mining, it's other types of mineral extraction as well, and a lot of different players involved. So of course that's a bit different. But still there is also the issue of like similar issue of environmental pollution and land degradation, and you know, people have become affected differently in different ways, and their livelihoods being impacted in different ways. So I mean, there are similar issues reported from the DRC as there is from Zambia. And in terms of copper being copper from the DRC part of the production in Zambia, I cannot say to what extent that's going on, but definitely I think it is happening, that there is import to Zambian smelters from the DRC as well. And I mean, to some extent, it's probably done in a transparent or legal way, at least. But of course, there's also a huge risk of illegal illegal mining and import of minerals that has been illegally extracted that come into the supply chains and production lines of Zambian smelters, of course, as well.
Yeah, thank you, Lynn, also for the participants. So the cobalt supply chain in Congo will also be stressed by Erik Molders on Thursday. So yeah, this will also be more related to DRC. A next question is towards Daniel. Who are the buyers concerned by this supply chain? Can you explain a bit?
Yes, this is one of the issues because initially the trader which became an owner of the concentrate in Bulgaria, in port of Burgas, it was an old European commodity trading company. It was Louis Dreyfus company, but and even at that time, we didn't knew where the final materials go, because the output of the Namibian smelter is just the blisters of black copper. Even the gold is not extracted there because the taxes in Namibia about gold are very high. So the material exported out from Namibia was a black copper blisters. And we never knew where all this is sold, but we assume that it can go to the stock exchange. But 2 years ago, the metal department of Louis Dreyfus was bought by a Chinese company. So now we think that all these materials are just feeding the Chinese economy processes, and the problem is larger because, for example, in Namibia they have relatively big uranium reserves, and most of these uranium mines have been closed during the 80 and the 90 because the price was very low. The price of the uranium was low in that time. But now we see Chinese company coming and reopening this mine because they are not interested from the money, from the market conditions. They are just bringing the materials back home to serve the Chinese economy, which serves all of us. So no, we don't have any evidences how the materials are continue in their way. And on top of that, during our ICT project, we identified that the smelters itself, many of the smelters have a secret clauses with buyers. So this is another artificial barrier to get to this very valuable information. But now the European Union, the European Commission is starting a large process for improvement of the critical raw material initiative. And we hope that during this process, we will be able to put all these questions in front and eventually improve significantly the reporting, the international reporting.
Okay, thank you. There is another question for Daniel, so we can use this one too. So after the decommission of the arsenic facilities in Namibia 2017, have the PM used safer and more responsible procedures, or have they simply moved, or have they simply moved the process to another country?
Well, the arsenic fabric, the arsenic facility, was producing from the common arsenic dust coming from the smelting. They have been producing arsenic trioxide, which they have been pretending in 2015 that it's a byproduct, that's a sellable product, and they have been selling it to companies in South Africa and Malaysia as a constituent for wood treatment or pesticides. But then, and this is maybe very important, because then came the European ban on products that contains arsenic. And this influenced so much this very far from Europe market that practically the company were not able to buy to find buyers of big quantities. So they closed the arsenic fabric. They are not producing the arsenic trioxide anymore, and everything is dumped in the hazardous waste site. But as I said, the conditions of the site are improved significantly. So we believe that we don't have big concern about the releasing of this arsenic at the air or at the underground waters. But we will really insist that the arsenic vitrification technology will be applied in an economic scale, because if all these arsenic will be left just at in Namibian territory, even if it's well sealed, it's not something that we consider ethic. So we believe that the vitrification will work, and this will be probably a leading example to other companies.
Okay, thank you, Daniel, for this response. We have two more questions to Sharon regarding to the enlargement of the scale of this application, this new methodology. The first is on, it all looks very promising, but have you also conducted this lab experiment to a larger scale, and how do you make claims about low energy consumption, low environmental impacts, and low capex? Any references? And yeah, the second question is also a bit related to that, is the 100% efficiency corresponds to a laboratory efficiency, because 100% industrial yield is almost impossible to obtain. If you made a life cycle analysis on organic lixiviation life cycle, or how can you enlarge actually the scale of this new methodology?
Yeah, this is interesting questions, because currently we only have the lab scale research. All the conclusions are from our lab research, from our simple process. That's why I present in the last slide that if we want to implement this process in full scale, we need to study the pilot scale first to involve in the engineering study, including the energy consumption, life cycle assessment, all those studies, to really study the environmental and energy consumption in large scale. So those conclusions that I gave is from the lab scale research compared with the conventional process. Of course, the large scale study is really necessary in the future. You are on mute.
Thank you. And yes, we are looking forward also to see how this methodology can be used also by different companies. A last question also to Linda and Daniel. There are a large number of different laws and initiatives that attempt to deal with issues around minerals. Which are the most useful for copper, and what improvement in those laws or initiatives would help most? This will be the last question for today.
Sorry, Charlotte, can you repeat?
You're still muted, Linda.
Can you repeat the question? Sorry.
Okay, so the question is, there are a large number of different laws and initiatives that attempt to deal with issues around minerals. Which are the most useful for copper, and what improvement in those laws or initiatives would help most? If one of the two or both can answer these questions, Linda and Daniel?
Yeah, well, I can start. From my perspective, looking at like global supply chains and ICT products, more specifically as well, I'm interested in two legislations really being improved and coming into place. And the first one is what I mentioned, is the EU legislation on conflict minerals, which will come into force next year, which will require that importers and smelters in the EU will do human rights due diligence in their mineral supply chains of these conflict minerals. And as you so correctly, most of you answered in the first poll, it concerns then gold, tin, tantalum, and tungsten. And I mean, I would really like to see this legislation being widened in scope to really address more minerals, because mineral extraction is a very high risk operation in so many ways. I mean, not just the issues we have talked about today, there are so many other impacts we can see. So, I mean, really to make sure that traceability and transparency is improved, that we can see that, you know, working on other issues also in addition to conflict, also to widen the scope and not just include 4 minerals, because there's like 75 elements present in a smartphone. So we have lots to work with here. And also not to just be a legislation for smelters and refineries importing minerals to the EU market, but also to the ones producing the finished products, which would mean that all the large tech brands and other electronic companies would be forced to be reporting on how they perform their human rights due diligence in their mineral supply chains, basically. So I think that's one thing. Then there is also the process of the human rights due diligence legislation in general, which is also up for discussion and has been like passed by the European Parliament in support of that. So that legislation is also very important. But again, like on a local level, when it comes to legislation, of course, in Zambia, they have like legislation in place to actually address these issues. It's just like, but they're not enforcing it. So that's the issue. And I think that's like a reoccurring issue. So that's, yeah, in addition to that, that is also, of course, a major concern. Maybe Daniel wants to jump in as well.
Yes, thank you, Linda. I will practically confirm your opinion. There are 2 lines. There are the international line and the national. And I can freely say that although we have probably the most elaborated legislation in Europe, and although Bulgaria is an EU member country, our national control on the mining operations is not as good as has to be. We have a number of reports of the National Chamber of Audits saying that primarily the control of the metal concessions is documentary. So it's very, very rare that civil servants will go and really measure at the mine what is the content of the concentrate that is leaving the country and what are the conditions there. But a part of the national issues, the international is really up to the consumer. All of us means, and if we all require higher standards of the supply chain and the way that the materials are obtained, that the politicians will respond on that. It is a long process, but we see how for at least for the last 15 years that I'm working very close in this sector, how the standards have significantly improved. And now we are discussing those supply chain issues that have never been regarded from the position of the human rights issues or environmental issues. We see how now this comes and be implemented, turn to the legislation. And I also underlined this very simple case of the arsenic trioxide, how the European ban on these substances led to significant shrink of the market of the arsenic trioxide. And this, of course, improves the practice on not only in the Namibian case in Tsumeb, but in many other fabrics all around the world. So I think that's the right way, but it will take time.
Charlotte, we can't hear you. I can see you speaking.
Okay, sorry, I was muted. So yeah, thank you once again to the three keynote speakers, Daniel, Linda, and Sharon, to explain us how there are still many challenges from social and a more technical background and perspective in how we can improve the ICT copper supply chain. We invite you to have a closer look, to all of you, to your company and organization, where your ICT is coming from, where you buy it and how it was produced, and where the metals come from who were inside. Just having a better idea, better overview from where it all comes and what are the conditions will help us all to improve this. There are some more questions asked in the chat box. We are not able to address them all because we are already 5 minutes over time, and it's important to stay to the schedule. So yeah, you're welcome to send an email to the keynote speakers to ask your question and to have an answer. And we will share later on the video recorded, the blog spots, the drawing Iris is making, and yeah, also the report. So thank you once again, and hope to see you all again next Thursday on our second webinar of this series of webinars. Thank you very much.